Okay, hello everyone. So this is the second section of number patterns, sequence, and series. So this session, let's solve some different type of questions, not the ones that we did in the first one. So like the first question, 2.1 is an arithmetic sequence. We need to find the next terms and the 100th term and which term is 15,002. So that looks like all seems good in order. But the two questions, 2.2 and 2.3, seems a little bit different. Let's have a look in these two questions and spend time on them. So because there is log, it may just confuse you, but the idea of sigma notation, it is basically the sum. Remember, it is the sum of the terms, which terms we are talking about, whenever n from n is equal to 1, and then n is equal to 2, and n is equal to 3, because it stops at stop. We need to stop at 3. We will start for n is 1, and we will stop at 3. So that makes only 3 values. So we will put 1, and then we will put 2, and then we will put 3. So let's do that. So let's write what is the left side of equation is. We have log b to the power of 1, and then plus, because this addition, log b square, and then plus we have log b cube. So that's all. Now it's basically b square and b cube. Now all the bases are same. How does it work with the logarithmic functions? Like, remember, it's actually related with some rules of log. Now that's why it may be a little bit tricky, but according to the rules of log, the power in front, the power of the term inside actually gets into as a coefficient. Okay, so there is 1, so 1 is 1, so it doesn't make a really big difference. But that comes as a coefficient. So when you remember and apply this rule, basically things become easier. That is log b plus 2 log b, and then plus 3 log b. So now we can actually add them up. As you see, it is log b and 2 log b, so it makes 6 log b. Now I can write what is on the right side. This is 12. See, we find 6 log b is equal to 12. From then, log b is 2, if you divide both sides by 2. Now, this last step, remember, if the base of a log is not written, that means it is 10. And we can understand the jump rule. We can apply the jump rule from here. What is that? 10 to the b is equal to 10 to the power of 2. The base is base. So that's how we end up the value of b, which must be 100. So this rule of log is not given in the formula sheet. It works for any bases, any types. They may not state examine, but in case you have such questions, you just need to, maybe as a suggestion, you can think of using calculator to notice how does the relation goes in terms of remembering the logs. But understand this jump idea. Okay, let me write jump here, because that's definitely helpful in even finance or in any number pattern questions, sometimes in inequalities. So that jump idea is important to find the missing value. So what is the jump idea? Converting logarithmic expression to an exponential expression. Okay, because when it is written in an exponential expression, that's kind of easier. That's why that jump idea is quite important to remember, from log to exponential expression. Okay. Now 2.3. So such questions, when we are given different terms of a sequence, we have a method. What method is that? Let's see. This is a geometric sequence. In geometric sequence, the 8th term. So let me write the idea, like if it were arithmetic sequence, then your terms goes like that. There is a plus d, there is a plus 2d, and so on. Like the 10th term is a plus 9d, you know that. But when there is geometric sequence, so how it goes, it is a is the first term, there is ar, there is ar square, and so on. And the 10th term will be ar9. So this idea is what we are going to use. So because if it were an arithmetic sequence, we will solve simultaneously, somehow equating or subtracting both sides, whatever. But because it is geometric, that's with the ratios, we will use the ratios. But nothing is wrong. Let's write the one above, the bigger one, the one above. So it is eighth term is normally 8 times R7, and this is given as 640. And the third term is what? 8 times R squared is the third term, and this is given as 20. So we will write the ratios, like when we divide the 7th term and the third term, basically T8 over T3, the ones given. So the a's will cancel. There is a to the power of 5. And 640 over 20 is 32. So that will give me an idea. If I take the fifth root of both sides, basically, I will end up the value of R. So from here, I can tell you the value of R is 2. What to the power of 5 is 32? 2. So the value of R is 2. Now, if I know R is 2, I can actually find any number that we can have. So do I know the first term? No, which is 8. Do I know the second term? No. Do I know the third term? Yes, I will write it. Then the fourth term, then it goes. Fifth term, sixth term. See, I will be writing this, don't worry. So the question is only required the sum of first 7 terms anyway. So the ones that we know was the third one. Let's write it again. The third one was 20, and the eighth one was 640. And there's a ratio. We ended up the ratio is 2. That means the next term after 20 is 40, and after 40 is 80. After 80 is 160. After 160 is 330, and after 320 it's 640. You see, that's right. What is the term before 20? Then it must be 10, and before 10, then it must be 5. Actually, which is the value of A. Anyway, the question is asking only the sum of first 7 terms. So I'm not going to add all 8 of them. So I can just ignore 640. But the sum of these numbers is the answer. All right. So that's what the question asks. So you can just smile and add them up. It was a nice 5-mark question. So that understanding that first idea, arithmetic and geometric sequence is there. So here we use the ratio, we divide 8th term by the 3rd term. But if it were arithmetic, then we will use another method, which is solving simultaneously. Okay, so this was a bit different question, one they used to ask more. Look at this page, anything interesting? It says, okay, it's just a mixed term, mixed sequence. So we can just give some thought here. What's that? Write the 10th term. So we have the odd terms as always 1. We can see that there is first one, there is third one, there is fifth term is 1, 7th term is 1, and then the even terms, the second term, okay, the fourth one, so that is T2, so that is T4, that is T6, and that is T8. Now they ask the 10th term. So I can write the next 2 terms actually. After the 8th one, it is going to be 1 again. And it will be something, which is the question. And then it will be 1 again, and it will be something, and it will be 1 again. So I can say that. So the question is basically asking, what is T10, the 10th term? So what should I write there? So then we will basically observe the condition. We have a sequence from the odd ones. That's 1, 1, 1, 1 always. And we have the even terms. Even terms goes like what? There is 2, there is 5, there is 8, there is 11. So you can see a pattern here. They increase 3 by 3. So you can just tell me the next one must be 14. So that's the answer. Okay, so the next one is 14. Then the next one, you add another 3, 17. Next one, 20. Anyway, that's it. But when they ask the sum, you see that's the sum. So we will use sum formula. But sum of 100 terms means what? So it is a sum of 50 terms of what? 1 plus 1 plus 1 plus. So basically we will be adding 50 times 1. It's 50, but plus the sum of 50 terms of what? That's because there are two different sequences. Each one has 50 terms. The second one is 2 plus 5 plus 8 plus 11 plus. It goes like that. I don't know what the last term. It doesn't go forever, but they have 50 terms. Now, the first one is kind of easy. 50 terms of 1 gives us 50 times 1. Basically, it is 50. But now, the 50 terms of the second sequence, so I have to use that formula, which is Sn formula, which is n over 2, 2a plus n minus 1d. And to be able to use this formula, I actually need to know what is my a, the first term, 2. What is my d, the difference, 3 by 3. What is my n, number of terms, 50. So I actually know everything. So then I can just find by substituting into the formula, and I have to add the answer, whatever the answer, with 50. So because there are 50 ones, they make 50, and there's the other part, whatever they make. We can get it calculator using the sum rule for an arithmetic sequence. Okay, so I hope that's clear. This one, there is a story, but it doesn't look quite different. You can see the increase by 6, then increase by 8, then increase by 10. So yeah, it's a quadratic sequence. You can go from there as we did. You can say 2a is equal to 2. So that's 3a plus b is 6. And then 0 gives us a plus b plus c for the general term. That's how it works. All right, it's not a different question. Now, let's see. We are given a quadratic pattern, which has the first difference and second difference is given, and the first term is given. So it says right next two terms and determine the general term and which term. Okay, just to have the first two terms, the rest seems same, but just that first two term point. So we have 1 and we have something and we have something and something. So it carries on. What we know is the difference. First difference is -1. And then the second difference. So the second difference is the common difference. So when you say first difference is 1, so the next term is 1 minus 1, sorry, minus 1. So next term is 1 plus minus 1, which is 0. So, but then the second difference and then the other difference. So we are given actually the second difference, and second difference is -2. And the second difference doesn't change. So then -1 plus -2, it gives us -3. And then another -2, it gives us -5, and so on. So it will carry on like that. So now, what are the terms then? 0 minus 3 gives us -3, then -5, -3, -5 gives us -8, and it goes like that. So that's my pattern. So with this pattern, I can easily get the general term, and I can just equate to -63 to find which term at the end of the day is going to be -63. You see, there's a term here. One of the terms is -63. Which term? That's the question. That's the last question. Okay. Now, the arithmetic sequence. Writing sigma notation, we may not write the answer, but it's just what's important in writing sigma notation. You can say n or k here from the first term, so that we will write the general term, okay, and that we will write the number of terms. So that's the idea of writing in sigma notation, from 1 to number of terms, and here is the general term. So in this question, the general term in front, what is the general term? Tn is a plus n minus 1d. So do we know a? Yes. Do we know d? Yes. So that wouldn't be a problem. Can we get number of terms? We can. That's not a problem as well. That's actually calculated in the previous answer. 3.2, calculate n whenever, okay, whenever this sigma sum reaches more than more than 192. It's like an inequality question. And that's a bit problem because we don't know how many terms are there. So what should we do? As a general idea, understanding, write first 3 terms of this thing. We don't know how many terms, but we can write first 3 terms. And just be careful. The first term is starting from n2. Okay, so n is equal to 2. N is equal to 2, and then n is equal to 3, and then n is equal to 4. It will carry on till n is equal to n. So we don't know what n is. There's a term. So for the first one, n is equal to 2. It gives me 2 times 2 plus 1, which is 5, and 2 times 3 plus 1, which is 7. 2 times 4, 8 plus 1, which is 9. So it carries on like that. It's kind of the sum of odd numbers idea. So, and then there will be the nth term. That will be Tn, which we don't know. So when does this sum become more than 192? Now, I mean, going through the terms one by one and adding them, not a very good idea. They don't expect it. But in geometric sequence questions, you can try doing that. But in this question, it may take some time, Like we have 5 plus 7 is 12, plus 9, 21, then it is 11, 33. So you'll be adding quite a few number of terms to see that not really what is expected from you. What's expected from you is using the sum rule because once you have it, because it is the sum formula, so we can use the sum of arithmetic sequence because an arithmetic sequence, not geometric. So we can use the sum formula, and to be able to use sum formula, in this case, we need to know what is A, what is D, what is N. In geometric, there is R. This one, there is D. So I know D, that first term is 5. A, first term is 5. I know D, they increase 2 by 2. I don't know N, that's the question. So anyway, I know the sum. So I already know the sum. Sn is, so let's make it equal to 192. We are looking for the first term. We are looking for the first term more than 192. So it can be anything more than that. So what will be my answer? Let's just think on it. My answer, for example, cannot be 4. Because if I say n is 4, the left side of expression becomes 5 plus 7 plus 9. So it becomes 21. When n is 4, it doesn't satisfy what I want. You see, what we want is more than 192. So 4 is not a good answer. It must be more than 4. 5 will not be enough. 6 will not be enough. You will get a number and you are going to say n must be more than that number. For example, n can be 100. I know 100 will definitely be an answer. Why? Because if n is 100, the 100 term is already more than, is already 201. You don't even need to add the previous terms. But basically what is asked is the smallest term satisfy this condition, the smallest n satisfy this condition. So that I can tell you, let's say n is more than 35 or n is more than 21. I need to find that number. Otherwise, anything above that number, like 100 is an answer, 200, 150, 1000, they all possible answers for n. But we don't have a specific answer. Our answer must be in the form of like n is equal to more than a specific term. After that term, the left side start becoming, let's say that way, it was less than 192, less than 192, less than 1, but after a term added, that will become more than 192. And that term is our question. You can basically get that answer by solving this because it's only n missing. You know A, you know D, you know the sum. You can use quadratic formula and from then figure out, even if you get a decimal answer, it must be a positive integer, positive number. It shouldn't be a decimal. It must be a natural number for n. So, but the value you get, you can just take the previous positive answer will satisfy the condition. Okay, now here the next one, it says first 2 terms of geometric series add up to 30, and the infinity is 54. And first term is A, common ratio is R. So find them. Okay, it's just kind of solving a simultaneous equation, I guess, because we are given what? We are given T1 plus T2, and which is A plus AR. Remember, that's how we write the terms of arithmetic sequence. A, AR, AR square, AR cube. That's how it goes, because it's arithmetic. Sorry, in geometric sequence, that's A, AR, AR square, AR cube. If it were arithmetic, what do we do? It is A plus D, A plus 2D, A plus 3D. So this is geometric, so that's why we write A plus A plus AR, that's it. So that first two terms add up to 30. Now, the question mentions infinity. So that means the infinity rule can be applied here. That means we have an R between -1 and 1, because otherwise we wouldn't have that sum. That comes together. So that's the convergency condition. Remember, that makes the series convergent. But anyway, I know that is 54. What is 54? That's my second equation that I can write. According to this second information, I can write A over 1 minus R is equal to 54. So that's my first equation. That's my second equation. So how can I solve them simultaneously? You may cross multiply, you may leave A alone. So the rest is just algebra, okay? There's nothing much to do with the sequence, the idea of sequence or anything. It's just try to solve this question. Like for the first one, I can say A as a common factor, 1 plus R, this is equal to 30. And for the second one, I can cross multiply and I can say what? It is 54 is, A is equal to 54 minus R. So now, I think you start thinking what I am thinking here. What is that? I can make that substitution. Instead of A, in the first one, I substitute 54 times 1 minus R. So I already have 1 plus R, and I know it is equal to 30. So that makes it quite nice, because from then things get easier and easier. Like what? If I divide both sides by 54, 1 minus R, 1 plus R makes 1 minus R squared, and the left side, right side becomes 30 over 54. What is 30 over 54, by the way? They both divisible by 6 to 5 over 9. Now, if you leave R alone, so I can take 1 minus 5 over 9, sorry, is equal to R squared. I take R from left to right and 5 over 9 from right to left. What is 1 minus 5 over 9? Is 4 over 9. So then it's almost done. R squared is 4 over 9. Can I have plus minus 2 possible answers? Yes, it can be plus minus 2 over 3. Oh, you see in the question, they tell me R is positive. So I have to choose the positive option. So using that, I will just choose the positive one. So I can erase the negative case. I can just say 2 over 3. Otherwise, you should be considering possible option for 2 over 3. So I got R. And how do we get A after finding R? That's easier. You just substitute that into one of the equations, into this one, for example. So when you substitute that, that will give you the value of A. That's good. Okay, so the first step of this solution, as you see, we have written what is given into equations. The sum of first two terms, geometric series terms are written as A, AR square, and so on. So the first two gives us this equation, and infinity sum formula is given already, and it's A over 1 minus R is 54. So just solve these two simultaneously. That's the idea. Okay, and is there anything different or important that we can mention here? There's a formula for a quadratic sequence given. That's nice. Time in seconds, the distance, determine the values of RS, okay, and then the nth term, that's a quadratic one, so you can use it. So then P is 8. Okay, it's just an application of quadratic sequence question. That wouldn't be much problem. Here, calculate M if we are given an equation with sigma notation like that. Now, what we do in such questions, again, let's think from the basics as what we can do. We can solve this in that way. So starting from 5, you see it starts from 5. Let's be careful, not 1. So we have for I is equal to 1, what do we get? For I is equal to 3, for I is equal to, 6, and for I is equal to 7. So we will write first 3 terms. Write the first 3 terms. Just to see and understand what's happening. The first 3 terms. And be careful how many terms we may have. Like imagine, we are not going to write anything for I1 or for I4. So that I1, 2, 3, 4 is missing. Our first term is for I5, then for I6, then for I7. It goes till I20. So then you can have an idea what's happening here. So what is my first term when I is 5? 3 times 5, 15 minus 4m. So that's 15 minus 4m. And when I is 2, right? Sorry, when I is 6, so let me write 15 minus 4m. Now when I is 6, so it is 18 minus 4m. And when I is 7, it is 21 minus 4m. And when I is 20, the last term is going to be, it will be what? 60 minus 4m. So these are the terms. Now, how many terms we are here and what's happening? We are adding them. That's a sigma notation. We are adding all these terms. And the sum is 472. Now, how many terms we have here? So there are 4 terms from 1 to 4, which we didn't write. So the remaining, we must have from the 5th till 20th, we must have 16 terms. Okay, good. Now, if we have 16 terms, how can we summarize and simplify the left side? So imagine I will just rewrite that condition. How can I rewrite that condition? I can write it like this. We have 15 plus 18 plus 21 till 60. How many terms we have here? 16. And now what else? We subtract 4m. So we subtract 4m how many times? 16 times. So it's basically minus 4m, minus 4m, minus 4m. And how many minus negative 4m's here? Same, 16. So that's my left side. I need to simplify the left side to understand what's happening. So can I get the sum of the 15, 18, 21, 60? Yes. Yes, I can use SN formula. Because I know my A is 15, I know my D is 3 by 3, and I know my N is 16. And then the second one, the ones we subtract, they are kind of easier, right? It is 16 times 4. What we subtracting is negative 64m. So that's just, we got it. That's not a big issue. But the problem is finding the positive numbers here. Okay, let's do that. Let's find that sum. So what was the formula? N over 2. That is 16 over 2. I'm not going to rewrite. Okay, let me write the formula on the side so you can see what is Sn formula. If you forget, 2an minus 1d. So I'm going to use this formula. Okay, I'll just write it. N over 2 is 16 over 2. 2 times a is 30 plus n minus 1 is 15 times 3 minus 64n. M, yes. So that is equal to 472. Okay. So what do we get on this side? We got 8 times 30 plus 45 is 75. So it's equal to 600.
It will be 600.
Yes, thank you. So it gives me 600. So this side is 600. 600 minus 64m is equal to 472. Okay, just subtract 472. Then you got 128. Then we are almost getting the answer. That means 64m is equal to 128, m is equal to 2. Okay, that deserves maybe more than 5 marks, but that's what we do to get m. You see, it's first of all understanding all these ideas starting from the 5th term, then the 6th term, then the 7th term, and then until the 20th term. Write a few terms to see what's happening. You can even write the last term, nothing is wrong. And you need to be careful how many terms written here. And you must be good in calculating this sum in terms of n. So that's why we split it into pieces. It's 15, 18, 21, 60, and there's minus 4, minus 4, minus 4, and all these minus 4 amps. So that gives me, that whole thing gives me 472. So when I figure that out, then I can solve for m. Okay, it was a bit different question. It was good to solve. And oh yeah, such questions, they are very famous. When they are given the condition for convergent as a convergent series, so that condition is actually giving me the information about R. So they tell me we have a common ratio which is between -1 and 1. And what is common ratio? T2 over T1. Or don't equate and cross multiply. If it is easier, you can even get it from T3 over T2, whichever you find easier. But don't equate them, cross multiply. It's not like finding X, you know, like there's a term missing, it's arithmetic sequence. So that's totally different, because I see many learners do that mistake. For example, let me just give you an example. You have 3x and x and 11. So like, what do you do when it is arithmetic sequence series, or what do you do when it is geometric series to find x? When it is arithmetic series, what do you do? That's my T1, that's my T2, that's my T3. You basically say T2 x minus 3 is equal to T3 minus 11 minus x, and you solve it. But when it is geometric series, you say x over 3 is equal to 11 over x. So you cross multiply and solve it. So we can solve x from here, and we can solve x from here for different conditions. One is for arithmetic series, one is for geometric series. But this is the question that only x is missing and there are numbers. The question here we have is different. We must find R in terms of x. Okay, fine. Let's say that find R in terms of x first. So then what is R? T2 x cubed over 5 over x squared. Basically, this gives us x over 5. So now you plug it into the condition they gave us. So -1 x over 5, 1 times everything by 5. That's the possible values for x. Any value between -5 and 5 makes this series converging. And like 2 is fine, because 2 is a number between -5 and 5. So that's good. And that's why when it is 2, I can find S sum. Nothing is wrong with, S infinity. Nothing is wrong with S infinity. And okay, S infinity is the easy formula, you know. You just substitute the values of x, value of x as 2, and according to 2, what is A and what is R? And then you can get the answer from the sum to infinity formula. All right. So like, what will be A? A is first term, it is x squared, which is 4. What is R? What we said, R is x over 2, which is x over 5, sorry, which is 2 over 5. So you know A, yes, you know R, yes, we can find the sum to infinity. All right, I hope all is fine. So that's almost ending our questions, but there is last set. Let's check, is anything again different, so we can have a look. Otherwise, we really not need to do that. Okay, write down the next two terms of the pattern. Next term of the pattern, the first one says, so is there any possible relation? It can easily be catched over there. So there may be a few more, because only 3 terms are given. There may be a few more approaches, but basically with 1, 8, and 27, you can like figure out the relation. It is 1 cube, 2 cube, 3 cube. So next term will be like 4 cube. So 64. And look at the denominators. It's always 1 more than numerator. So I can just say numerator plus 1. So basically it is 64 over 65. Like, this is one way. But it could be different possible correct answers if you prove, but this comes quicker to mind, you see. All right. Now, this question, this is the question where you say T2 minus T1, because arithmetic, arithmetic series. You just say T2 minus T1 is equal to T3 minus T2. That's how you solve for P. So since when you solve for P, the rest is easy. You just substitute the values. 2.3, anything different? It's sum to infinite series. It can be calculated because infinite series gives the idea. We will use this formula. And the good thing is we only need two values, which is A, okay, that's 5.6, and then which is R. So it is 3.36 over 5.6, whatever it is. So I know A, yes. I can get R, yes. So can I use the sig infinity formula? Yes, and get the answer, that's it. And the next question, it says again, converge. So the same thing, I can skip this question, but the idea is going to be T2 over T1, which is R, must be in between -1 and 1. So that's how you can solve this 2.4 question, 2.4. And the proof question, we have done it the previous session yesterday. So you can just go through how to prove. There are two proofs they may ask. Remember, arithmetic sequence sum and the geometric sequence sum. Just please go through them. It's possible. It can be asked, yes.
How often do they ask proofs in the exams?
Every second, every third year,
For
not
number
every year.
pattern.
Not every year, but no, they can ask. It's examinable.
Yes, sir.
Okay, then the last two questions, let's say for number patterns and for today, for this period. Now determine n, 1 to n. Now, because the thing is in the power, it's a geometric sequence. But let's say you are not very sure. You always do the same thing, what we said in the previous session. Write previous question, write first three terms. Just to have an idea more clear, write the first three terms, okay? So what does it mean? It means when k is 1 here, because it starts from 1, you see, it doesn't start from 2 or 5. Then when k is 2 and when k is 3. So then it is the nth term when k is n. So we don't know the n. So that's the question anyway. Now when k is 1, so it is 3 times what? 2 to the power of 1 minus, so it's 2 to the power of -1. So it's basically 3 over 2. Plus when k is 2, it is 3. When k is 3, that is 6. And then it carries on. You can write, you don't really need to write. Because it gives me about the A, it gives me the value of A, first term, and it gives me R. You can see what's happening. It's always multiplied by 2 and 2 and 2, so R is 2. So I know A, I know R, and I ask to find when it reaches more than 3070. Okay, now in geometric sequence questions, I don't strongly suggest, but it works because they grow fast. You can actually keep writing. And you have your calculator, like you have 6 already. You can say 6 times 2, that gives me 12, times 2, 24, 48. So, but show that the sum that you are adding that many numbers gives you 3000 and something. So let's do in that way first before solving, because the other way when we solve, we have to use log, and I'm just worried about that. That's why I'm just showing this. So let's just write the first T1, it's 1.5, then T2, we have 3, then T4, yes, T3, we have 6. So I'll write the other terms.
Is it the first sum 3? Because you used 0 to find the first sum, but they say that we must start with 1.
Yeah, so when you substitute 1, it's 1 minus 2. 1 minus 2 is -1, so 2 to the power of -1. So 3 times 2 to the power of -1, 2 to the power of -1 is 1 over 2. So it's 3 times 1 over 2, so you get 3 over 2. You can use calculator, it may give you 1.5 or 3 over 2. And when k is 2, it's 2 minus 2 is 0, 2 to the power of 0 is 1, so 3 times 1 gives us 3. So we will be writing more terms. So it goes 12 and then 24. Let me write, 24, then 48, then 96, What does it come after 96? 192, 192, then times 2. You can see 384, and times 2, you get 768, and times 2, you see we are getting, it's already 1536, and when you times 2, you get 3072. Now, definitely, we are not going to use this 3072 because we want the sum 3070. So I cannot add that last one. That means the sums that we get must stop at 1536. And which term is it? So that's T4. That's 5, 6, 7, 8, 9, 10, 11. So that's the 11th term. So you can just say they add up to 4.5. If you add the next term, 10.5. If you add the next term, 22.5. So you can keep adding. And then the last one, when you add it, it must be 3070.5. So that's why n is 11. So we must add 11 terms. The other way is using getting the sum with making use of log, with the sum of formula with log. Let's do that. Let me put an arrow down there, and let's do that in that way. What is the formula for the sum rule? It is Sn, arithmetic sequence, ARn minus 1 over R minus 1. It's not really bad, actually. Let's try. So we want this sum to be 3000 and whatever. So I know A, 3 over 2. I know R, n, and then that will be 2 minus 1. So this is going to be 3070.5. Now, the idea is solving this equation. See, how can we solve this equation? Now, numerator is already 2 minus 1, so it is 1. So you can kick it out. And then to get rid of 3 over 2, I times everything by 3 over 2. I divide both sides with 3 over 2. So 3000.5 divided by 3 over 2. If you divide it by 3 over 2, then what do you get? Let's see. We got 2047. Let's do that. So that's 2n minus 1 is 2047. So what is 2n? 2048. Here you have to use log, or you can just say the answer because the perfect power of 2. So calculator gives us 11 as the same answer. So you can find 11 in this way, or you can find 11. You can show 11 in the first way, but you need to know the second way as well, because some questions, you have to use log. You may need to understand the jump idea. So that first one was just an option. And the last question in arithmetic sequence is what? Let's see, consider the following sequence, determine nth term if this given the sequence is quadratic. Okay, that idea they tell us it's quadratic, already quite good information. I don't need to worry about what's all these things. So just find the values. What is T1? And what is T2? What is T3? Numerical values. Just use calculator anyway. What is T4? So what they make when you substitute the values, like 2 cubed is 8. 8 minus 1 is 7. So it's 7. 3 cubed is 27. Minus 1 is 26. 26. It's 13. 4 cubed is 63. 64 minus 3 is 63. 21. And then 124 minus 3 is 31. So what do you see? What's happening is the difference increased by 6, increased by 8, increased by 10. The second difference increased by 2, increased by 2, whatever. So it's all comes to the same point. 2a is equal to 2, 3a plus b is equal to 6, and a plus b plus c is equal to 7. So I can find whatever the sequence is. That wouldn't be a problem. Okay. So it was some more lovely questions in this part. We'll we'll be doing functions as a next period.